What is going on, everybody? It's Conrad back with another video, and today we are finally going to be using AI to make a butt ton of money, because the most important thing in life is increasing shareholder value. So let's do just that. Let's get rich, let's beat Wall Street, and let's do it all using just a couple lines of Python. All right, so first things first, you're going to go to collab.research.google.com, and here we are. We're going to create a new notebook. Don't ask me why my Google Colab is in Spanish. And we're going to call this our AI Money Maker. And now first things first, what we're going to do in order to make money off the stock market is, put simply, create an AI model that is going to predict the price of a given stock. So we'll be able to see if the stock's going to go up or down and profit accordingly. So in order to do that, we need to get a good data set. We need to find a good stock that's going to be very cyclical, so it's going to be easier for the model to create. And so in order to do that, what we're going to do is we're going to import the Yahoo Finance API. So we're going to say import Y Finance as YF. Run that. And next things next, we're going to now download our stock price data set. So like I said before, we need to find something that's cyclical so that the AI model will be able to really predict what's going on here. And for that, I've decided to choose a shipping stock because according to my finance nerd friend, apparently these shipping stocks are super cyclical, based on the seasons and I don't know. Anyways, so in order to do that, we're going to set stock data equal to YF, which is our Yahoo Finance API, .download DAC, that's the ticker, and then we're just going to get about the last 10 years of stock data. And you can replace this with whatever you want. If you want to choose a different stock to predict, if you want to change the time zones, the window, whatever it is, feel free to do that. But for now, we're just going to be using this. And then let's actually take a look at our stock data. So I'll run that. And you'll see we have the date, we have the open, the high, the low, the close, adjusted close, and the volume. Awesome. And so next what we're going to do is we're going to convert all of these numerical values into values between 0 and 1. And what this will allow us to do is this will allow the model to better pick up on the patterns that are present in the data. We're basically scaling our features so that they're more interpretable for our AI model. So we're going to say from sklearn.preprocessing import min-max scalar. Perfect. And then next what we're going to do is we're going to say scalar is equal to min-max scalar, and inside the parentheses we'll say our feature range is going to be between 0 and 1. Perfect. Now that we have our scalar, let's actually scale our data. So we'll say scaled data is equal to scalar.fit transform. And then in here, we're going to get our stock data, but we're only going to be working with the close price. That's the only feature that we're going to use. Again, if you want to predict other things like the open, the high, the low, whatever, you can do that as well. But for now, we're just going to look at the close price. And now for whatever reason, we're also going to have to reshape everything. So .values.reshape, and we're going to reshape -1, 1. And that's just because we imported it with pandas, and it gets a little picky about what shape the array's in when you input it into the scalar. But whatever, I digress. Okay, so that line ran with no problem. Next, what we're going to do is we're going to create our data set. And in order to create our data set, you may say, but we already have the data set, is we're working with a sequential model here. We're working with sequential data. And so what we need to do is we need to sequence our data out based on a certain window or a certain time step so that essentially the model can pick up on the patterns as it goes on. Because the idea is we want the next values that the model is predicting to be very much based on the previous values and go sequentially like that. Because honestly, stock price data is like the prime example of sequential data. It's not categorical. It's not like, is this an egg? Is this not an egg? Is this a sandwich? Is this not a sandwich? It's not regression, like if you were predicting housing prices. It's something that's very sequential because it's time-based, it's sequence-based. So we're going to import NumPy as NP, And then now we're just going to create a little function that ChatGPT helped me out with. Create data set, and we'll have one of our parameters is data, and then the second is time step. All right. In there, we're going to create our x and our y as just empty arrays. Perfect. And then we're going to say for I in range, and we'll say the length of the data that is being inputted into our function minus the time step minus 1, just to make sure that the index values are right. We're going to say x.append, and we are going to append data at I to I plus timestamp, and then 0. And, oh, sorry, I accidentally ran that. And then we're going to do the exact same thing for y, except for it's going to be y.append data square brackets I to plus time step. I see I've spelled step wrong. Comma 0. So what is this saying? This is essentially saying that our x is going to be all the values leading up to the y value, and then our y value is just, well, the y value. Perfect. And then, of course, we're going to need to return something outside of this function, so we'll say return, and we will return the np.array of our x, as well as the np.array of our y. So run that. Okay, everything looks good. Now let's create our data set. So the first thing that we're going to do is we're going to set time step equal to, we'll just say 100, and you can change this. This is basically just the window that we're using, so you can change this to whatever you want. I'm just going to say 100, which would be, I guess, 100 days. And because we're going over a 10-day period, or a 10-year period, excuse me, I think that's fair. But again, you can adjust this as you like. We're going to say x and y are equal to create data set, and then in here we need to put in our data, which of course is scaled data, and then our time step, which we set equal to time step. Perfect. So we'll run that. Okay, everything's good. Our function didn't break. Next, what we're going to do is we're going to create a training set and a testing set. So this will allow us to see if our model is like actually doing its job or not. So we'll say the train size will be equal to 0.8. So we're going to save 80% of our data for training the model, and then use that last 20% for testing the model. So now that we have our train size set at 80%, and of course you can change this as you like, what we're going to do is we're going to split up our data set so that the first 80% of values will be for training, and then the last 20% will be for testing. So in order to do that, I'm just going to run this. So xtrain xtest is going to be equal to these parameters, and this way we've kind of chopped our data up into 4 pieces: the xtrain, the xtest, the ytrain, and the ytest. So for those of you who are a bit more familiar with machine learning, this should be pretty familiar to you. Awesome. And now it's actually trying to build the model. So like I said, we're going to be building a sequential model, and the type of deep learning model that we're going to be building is called a LSTM, which stands for long short-term memory. This is like the precursor. So if you think of ChatGPT, right, that's using a transformer. Before transformers, there were LSTMs. And so LSTM is just a way of a model being able to predict sequential data using long-term, short-term memory. And so the idea was it was kind of based on like human biology. It's still a pretty recent model. I mean, everything in AI is just been going so fast. But for now, I thought the easiest, the simplest, and surprisingly accurate way to do this was just with an LSTM. So that's the model that we'll be using. So we'll say from Keras.models import sequential, and then we'll also need to import our layers. So from Keras.layers import dense, and LSTM. And so dense, this is just your standard neuron that you have in a neural network, nothing too fancy about it. And we're going to be using those as well in our actual neural network structure. But put simply, this is an LSTM-based model, which is going to allow us to predict that sequential data. All right, and so now in here, we'll say our model is equal to sequential. Perfect. We'll say model dot add. So we're going to add a layer, and this will be the first layer of the model. So we'll make an LSTM. The number of units, the number of nodes of neurons on this first layer will be 64. We'll say return sequence equals true. You can read more about that in the documentation. And then we need the input shape. So the input shape is basically just going to be the size of our actual data set. So it's going to be the time step, comma 1. All right, awesome. So now that we have that done, let's add another layer. So we'll say model.add. We'll just say LSTM. And we'll just give it 64 neurons again. I like to use base 2 when I choose the number of neurons, but again, you can do whatever you want. Let's add another layer just for giggles. And we'll make this one a dense layer, also with 64 because I'm boring like that. And then we'll finally have model.add a final dense layer, and this will give us our actual value, so it'll only have one neuron because we're only outputting one value at a time. Perfect. So we'll run that. Okay, everything looks good. Now it's time to compile the model. So we'll say model.compile. And we need to choose our optimizer. So the optimizer is going to be the algorithm that's going to be doing that gradient descent, that's going to be trying to make the model as accurate as possible. And generally speaking, the best function to do this is called atom. So we'll just use that. And then the loss, which is going to be how we're calculating our error, will be mean squared error. And for those of you who don't know, mean squared error is basically just you take the distance of your predicted value from the actual value, and then you square it, and there you go. So nothing too complicated. And then we'll say model.fit, and of course we're going to fit the x train to the y train. Epochs, so an epoch is how many times the algorithm or our model is going to loop over the data set. And so we have a pretty big data set, so I'm just going to give it, say, 10 epochs, nothing crazy. And the batch size is how many items we're putting into the model at a time. And so depending on how good your hardware is, you can raise it or lower it, whatever you want. In this case, I'll just say 64, which works fine. But again, this is not a super important number for the level that we're at right now. And we're going to see that the model has started training. So we're going to wait a couple minutes, and we'll see how good the loss function is, and then also look at our results.
A few moments later.
All right, so our model is done training. You can see with each iteration of the data set, our loss or our error has gotten lower and lower. Our model has gotten more and more accurate. Now let's see how well it does on data that it's never seen before to make sure if it's overfitting or not. So in order to do that, what we're going to say is we're going to say test loss is equal to model.evaluate, and we're going to evaluate the x test to the y test, and then we'll just take a look at test loss. So I'll run that, and you can see this is about the same as this, and there we go. So model's not overfitted. Looks like things are working as they should. And at this point you may be saying, okay, so it's cool that like the error is low, but like how do we actually predict the stock prices? Like we've obviously made a model to predict stock prices, but how do we actually show that we're predicting stock prices? And so in order to do that, what we're going to have to do is we're going to have to make some predictions on, say, the x test, and then we're going to plot those predictions with the actual value. So what we're essentially going to do is we're going to show our x train, so all the stuff that the model trained on, and then we're going to show the y test and also the prediction of the x test. So what I mean by that is we're going to show how our model's prediction of what the stock values were going to be compared to the actual stock values. So in order to do that, we're going to create a variable called predictions. We're going to set that equal to model.predict x_test. And then something that's really important to note here is that we scaled our data. And so what we're going to need to do is we're going to need to unscale it so that we can actually plot our values. So we'll say predictions is equal to scalar.inverse transform and then our predictions. So this will give us the actual value of the stock and not just the scaled number that we put into our model to make it work better. So I'll run that. Right now it's predicting all the values based on our model, and they're all in the predictions variable. Perfect. So now let's actually create our other values so that we can make a good plot to see what our data is actually doing. So we'll say our original data is just going to be equal to stock data, the close price, values. Perfect. And then next what we have to do is we have to take these predictions and we have to put them in such a way that we'll be able to plot them. So I'm going to say predicted data is equal to NP empty like original data. So we're creating the size of like an NP array, just making them all nan. And then essentially what we're saying is we're just reshaping the predictions, putting the actual predictions in there, and just making things all nice and pleasing to matplotlib. So now let's actually import matplotlib, which is going to allow us to plot our results. So import matplotlib.pyplot as plt. We're going to say plt.plot, and we're going to plot our original data. So I'll run that. And you see this is the value of the stock as we go through days. And essentially this last 20% right here at the end is what the model was trying to predict just by knowing what came before. And so in order to do this, what we're going to do is we're also going to plot, we'll say plt.plot our predicted data. So I'll run that. And you can see right here that orange, that second layer on there, was our predicted value. So scarily accurate, not perfect, but very, very accurate, very well prediction of the closing price based on just the closing prices previously, which is freaking crazy. So you may wonder, okay, so we did well on the test set, we can see that, but what if I want to predict the stock's value moving forward? And so this gets a little more complicated because obviously when you don't have data from what came previously, you're using the predicted values in order to predict future values. And so essentially the stock price can get out of hand very quickly in your model and it can start almost hallucinating. But if you want to predict, say, a couple days in advance or whatever it is, this should work more or less okay. And of course, you can also adjust the timestamp to deal with that as well. But what we're going to do is we're going to create a variable called new predictions. And we'll set that equal to model.predict. And we'll just say x_test. We'll get the last 90 values of that, i.e. 90 days. Run that. And we'll say new predictions is equal to scalar.inverse transform, because remember we have to make it into the actual price format and not the scaled version. New predictions. Okay. And then after that, we'll say our predicted data is going to be equal to np.append, and we're going to combine the predicted data, which was what we had here, this orange, with the actual new predictions that we made. So essentially, we're going to be able to see beyond this blue line, see beyond what's actually in our data set, and appear ahead into the future. All right, awesome. And now let's actually plot our predicted data. So all we're going to do is we're going to copy the exact same code that we have above, because remember all we did was we made predicted data just a little bit larger. We opened up its window, and we're going to see how everything looks. So I'll run that, and you can see this little squiggly line right here with no blue behind it. Those are our next future predicted closing values. And just like that, guys, y'all have predicted the stock market. Make sure to increase shareholder value. Make sure to increase your personal value with this and make as much freaking money as possible. I love you all. I hope that this will help us make money. I will have to say I actually do not use this algorithm in my trading. So just putting that out there just for transparency purposes. But thank y'all so much for watching this video. Obviously, by the time you see this video, you'll be able to see how accurate these days are. So just look at our window here from February 21st, 2024, and then we went just a couple days into the future. See how well we did on our predictions, see if we were correct or not. And yeah, smash that like button. Love you all, and have a great rest of your day. Peace.